I wanted to start with welcoming our guests to this torture chamber. Um, and that would be Tyler Johnson's on, and Tim Large is on, and Greg Thayer is on. And I'll send a couple of people that's to the recording too. So thank you guys so much for they actually Greg and Tyler were actually victims, I mean students themselves of this. So they went through the whole thing. So thank you guys so much for being part of it. Before I start with the presentations, I just give everybody an update on where we're at. This is good stuff. This is about as good as it gets because I think this is the first class where I think 17 started and 17 finished. Usually I get, you know,
Hey.
4 or 5 casualties along the way. They just have boredom usually. But everybody finished. The exams obviously were, you can see here, the homework. This is the best I've seen also. For how many times I've done this in terms of the whole group. Um, I want to thank also beforehand our team leaders for the final project, Jason Rose, Ulrich Steele, Marcus and Meg from PTA, and Marissa from Ulrich Steele. So I think this is kind of, this is the course, as you guys remember, I guess remember, we started with Pareto. These are our first homework. Then we got into SciPoc, or you can do a process map if you wanted, a swim lane map. So a couple of high achievers did both. The people that sit in the front and they're always early, like a couple in this class. Then we got into this descriptive statistics like crazy, um, all that fun stuff. And then we got into inferential statistics, um, normality. I'm not sure, when Greg, for example, when you took the class, I'm not sure I asked everybody to do a normality test. That's a fun one. We got into hypothesis testing like crazy, single sample t-tests, ANOVA, Man-Whitney, chi-square, and then my favorite tools, correlation and regression. Love those. There is a person on this call, Greg Thayer, too, from PTA, that his favorite, he actually does hypothesis tests. He might be one of the only people on earth that likes it and uses it. Um, sorry, Greg. You can tell me to shut up anytime you want.
No, just feel free, air all my dirty laundry. It's fine.
Yeah, you're dirty laundry. And then control charts we did like crazy. Um, and then we did some cumulative sum stuff with the yogurt, my yogurt shop, etc. So it was a long 14 weeks. Just had a blast with you guys. So with that, Marissa, are you here? Or
I
I'm not.
am.
Okay, so are you gonna run this once I
Yep.
pop it up? Okay, let me grab it. And I think it's thankfully, I don't know if anybody used my health data, any of the teams, but I know I have two right here that didn't. So that's good. And Marissa, do you want me to just you could just direct me to move the slides?
Sure.
Okay. All you.
All
Uh
right. Hi, folks. Congratulations on surviving. Our team decided to do scrap data for the company Atlas Stamping and Manufacturing, and we decided to try to make our data talk. So we can. So the Essentially, what Atlas Stamping does is they take data each week and they use that data at the end of each month to determine the main reasons for scrap and to see if there's any major issues or causes going on. So the data that we decided to work with is actually from the month of July, and it's used to demonstrate the tools that we learned in this class. There's 10 major categories, and they were bad marking, bent, burrs, chip marks, chopped, dimensional misforms, scratches, setups, pieces, and visual defects. So essentially, we decided to conduct a SciPoc diagram to map the end-to-end scrap handling process, clarify the roles of supplies, inputs, and customers. And we wanted to outline each step. Um, it highlights where scrap is generated, sorted, and recorded. And this enabled us to target improvements in quality control, equipment maintenance, and material reuse for reduced waste and improvement and efficiency. So essentially, their process here is to receive and inspect raw materials. From there, they load materials into the stamping press. They perform the stamping operation. They sort and segregate usable parts versus the scrap. They weigh and record scrap by job. They store scrap temporarily in designated areas and arrange pickup. And then the last step of that procedure is to ensure handling meets environmental and safety standards. We also conducted a Pareto analysis. From this analysis, we can see that the majority of our scrap was concentrated in top three categories. And you can see that was chopped, chip marks, and visual defects, and that accounted for 83% of the total scrap. So we wanted to target improvement in these key areas and felt like that could significantly reduce the overall scrap. After conducting this analysis, we also concluded that the Pareto rule doesn't really apply here because 20% of the reasons for parts being scrapped do not make up 80% of the scrapped parts. We also conducted a correlation study. Some key observations based off of that is we were able to determine an R value of 0.91, which is linked to a very strong positive relationship between the day of the week and scrap quantity. As we can see here, there were a couple of peak days where highest scrap counts were observed on 7/8 and 7/15. This kind of suggests to us that maybe certain days might be more prone to process variation. We did also see low scrap days, and that was on the day prior, so 7/7 and 7/14. And we kind of wanted to look at those conditions to see if we could replicate what was happening there to improve our performance. Kind of the action after this investigation was to investigate staffing, equipment maintenance, and product scheduling on high scrap days to identify root causes and reduce variability. We also decided to do a fishbone diagram. As you can see here, we looked at our highest scrap category, which was chop scrap, and we looked at our methods, our machines, materials, manpower, measurement, and environment for different ways in which scrap was being, um, you know, basically made. And some of the things that we came out from that was like with our machines, like the press was misaligned. We could look at, our tooling to see a lot of it was dull or damaged, so maybe that has to be replaced on a more on a basis that's more regular. As well as, our environment, the temperature, the humidity could all affect our parts there. So based off of the four analyses that we ran, we determined some recommended actions. As far as our top scrap categories, we thought that targeting improvements on chopped, chip marked, and visual defect items would be the best use of our resources, as 83% of the total scrap came from those categories. We wanted to, during the SIPOC, we concluded that standardized setup and alignment procedures and enhanced quality control checkpoints during production would be helpful. When we ran our correlation, we uh, basically going forward, we're going to try to replicate best practices from low scrap days and investigate high scrap days for staffing, equipment, and scheduling patterns. And when we looked at the fishbone, we determined we should probably implement maintenance for press alignment and guide pins, as well as improve our operating training for that. And kind of the conclusion of all of this is, um, you know, just the next steps for us would be to update those procedures and introduce and process checks, as well as begin doing preventative maintenance that we hadn't previously considered, like the press alignment and guide pins. We want to do long-term enhancements such as strengthen our supplier quality checks because of the humidity and other issues affecting the parts that we were seeing, as well as continue operator training and reinforce standard practices. We'd also like to monitor and sustain improvements by tracking the scrap data monthly, like we are doing now, but making sure to look at the Pareto and control charts for each month as well. And then once we do that, we can review the results with cross-functional team to ensure improvements stick. So yeah.
All right. So who's on your team, Marissa? And how did you end up having to do all the talking?
I'm a yapper. It's okay. Um, so we had four people. We had let's see,
Yeah, Abhishek, right? You had to be
yep.
right. Had to be
And then
Abhishek.
you had Ed and Laura as well.
Oh, Adriana Boni and Laura Mario. Oh my.
Yes.
I tell you, that first slide you said we're going to make data talk. Boy, did you make data talk or what? Right? Because I mean, you could collect all the scrap data in the world. The one that really, like, I wish there was a way I could have reacted. 'Cause I don't see that anymore on the Zoom thing. And clapped was the correlation day of the week and the amount of, that's July, right? So now maybe I look back
Yeah.
at June really well done. Any guys that comments? Thoughts? I thought it was really well done. Really good.
I thought it was well done, very thorough.
Any questions for Marissa or the team? Congrats, guys. You're off the hook. Well done. Well done, Marissa.
Good job. Good job.
Ed,
Thank
Abhishek, and Laura Mario. All right, we're gonna go right into. I didn't have a chance to look at this one because I think I just loaded it up. And this is Marcus's team, Marcus and Jody, Riyadh and Bukola and Andrew.
Yep,
Well, you guys got five on your team, huh?
we do.
All right, who's going to be the speaker?
I will start us off. Our presentation is about improving the order fulfillment and an analysis of Hubbard Hall's process efficiency, and it's by myself, Riyadh, Jody, Bukola, and Andrew.
So in this presentation, we will review and evaluate the order fulfillment process at Hubbard Hall. We use a structured approach to identify opportunities for operational improvement that you'll see at the end. We wanted to better understand the current process performance and highlight areas where efficiency and reliability can be enhanced. So in this presentation, you'll see a swim lane diagram just to illustrate the order process flow. There's some statistical analysis regarding like normal distributions. We have some chart visualizations such as a Pareto chart and controlled charts. And then at the end, some recommendations based on observed patterns and performance metrics. Next slide, Bill. Unless I have control, sorry. So this is our swim lane that we put together. This is the order to shipment process. So what this does is this is going to show you the responsibilities and the different steps that each person does that they're responsible for within their responsibilities. What you can see here are it gives you a visualization and you can see possible delays. So we're looking at delays and time to deliver. So this would allow us to see where maybe something gets delayed, where there might be redundancies or errors in the process of order to shipment. Next.
Hey, Joe, I
Yes.
just gotta jump in because I just love this swim lane map because
Uh-huh.
in other words, like one, two, three, four, five, six lanes. Every lane represents at least an hour or a day or a weekend or a couple days of waiting. Just love it. Sorry.
Yes.
Sorry.
Okay.
I couldn't help myself.
Nope. Probably should have had a little more detail in there, but yes, this is good. Thank you.
All right. So we analyzed two key data sets from the order process. The first is the lead time, which is the total number of days from order to completion, and the order delays over 3 days. Instances where order took more than 3 days or beyond the expected timeline. If we can look through, we can see that the lead time analysis shows that the average lead time is about 1.47 days, and both the median and mode are, within 1 day. What this tells us is that it shows that most orders are completed very quickly, typically, in a single day, while majority of the orders move through the process efficiently. The skewness of 7.4 and the kurtosis of 125 indicates a small number of longer lead times. In this situation, these are very rare, but it's worth monitoring to ensure that, things stay under control. For delays over 3 days, the mean is 0.23 with the median and mode at 0. This tells us that the vast majority of the others are not delayed at all. However, the squareness of 18.4 and the kurtosis of 472 shows that in rare cases where delay do occur, they can be significant. And we try to identify and address uh, the instances, I mean, this few instances which will further strengthen overall reliability. Next slide. The key takeaways from this process is it tells us that overall, the performance is well, with most others being completed on time or ahead of schedule. But we have isolated outliers, cases where others are delays longer, and this represents or shows opportunities for target process improvements. Next slide.
So yeah, we created a normal distribution curve to understand if our data was in fact normal and in control. And from the data, you can see we have a partial bell-shaped curve. We couldn't get a full bell-shaped curve because we don't have orders below 0 days, or else we'd be sending early, which we cut out most of that data since it wasn't very helpful for us. The average, like the statistical summary said, was right between the 1 and 2 days, and that's shown on our graph where the peak is in that 1 to 2 day range. We do have a right-tailed skew, which shows we do have some outliers on the higher end. You can see that in the bottom graph there with the four dots between 30 and 50. Um, the process is partially out of control as we do have data points and the 3+ sigma range away from the mean. So our mean is around 1.5 and our sigma was around 2. So we do have data points that are away from that, so we can understand it's a little bit out of control, but not too terribly bad. And like I said before, the top graph has the outliers taken out to show it, make the data really talk to you. But in summary, that our data is mostly normal, but it has some inconsistencies.
Oh, now I can't wait to see the control chart.
Can you go to the next slide? Thank you.
Yeah, so looking at the Pareto chart, you can see that a small group of around 10 shippers makes up roughly 80% of the total delay days. Since our on-time delivery goal is 3 days or less, we track total delay days per shipper instead of just how often they were late. This lines up with Lean's vital few principle, where a small number of causes lead to the largest delays. Improving performance with the top 10 shippers could remove over half of all delay days and bring us much closer to the goal. Next slide. Thanks.
So we decided to do a control chart. And we actually have two control charts. Um, because one has kind of the outliers in it, and then the other one doesn't. So the reason I did that, or we did that, was because obviously the one with the outliers, it's very hard to see the trends. The one on the left. Um, but obviously I didn't want to leave it out because we need the data to scream, and obviously the one on the left screams. So um, the one on the right, though, would be more used to identify um, kind of trends that are kind of might be taking us in the wrong direction. Like maybe there's a busier season, so we're seeing kind of a trend going towards those upper control limits, which is hovering around like a lead time of like 7 days for us. Um, so that will allow us to kind of monitor the data live, um, as well as kind of see what's really far left field. Um, Next slide, please, Bill. All right. So in conclusion, our data for the most part is normal, but there's obviously some extreme outliers. So the next kind of step of action is to kind of do a root cause analysis to look further into what those kind of anomalies are, because it's not really, if our upper control limit, for example, is around 7 days, lots of these outliers are like something crazy, like 30, 40, 50 days. So kind of the game plan that we were thinking was using the data from the Pareto chart, which was to showed obviously lates by shippers, um, and to kind of filter the lates by the carriers that had the most amount of lates, and then kind of go from there. So we're kind of attacking the bigger part of the problem, rather than kind of getting lost in the weeds. In addition, we're going to continue to analyze this KPI via the control diagram, and also other KPIs that kind of correlate to on-time delivery and lead times. And that's basically it. Is there any questions?
A couple observations. Yeah, I think Atlas is aerospace, and they have zero escapes, knock on wood, to Pratt& and Whitney, their biggest customer. So it's interesting they picked scrap data and quality. And then you guys, Hubbard Hall is a 175-year company that survives by not satisfying customers, but pleasing, delighting them, and that's one way to do it. The one thing I was thinking as you're going through it was what would the correlation between number of open orders and days and orders over 3 days? Is there a correlation there? It might be cool to see.
That's a good point.
Well done, though.
Mm,
Well done. I'm telling you,
Thank you.
great
that's
I
job.
a
had a
good
question
that's
as
a good
well.
point. Oh, yep. Sorry.
I just love the way you guys are making the data talk.
Question.
You're using a whole bunch of different tools. It's just real cool, real good. How about our guests? Anything, Tyler? I mean, yeah, Tyler or Greg, or I think we got Doug
Yeah.
Thompson on now.
Yeah. So I had something. I'd be curious going back to that correlation there of I know you had it ranked by which suppliers or delivery people have the most late orders, but curious to see the correlation between number of delayed shipments versus total number of orders. Does one of them have a higher rate of delayed orders versus the others?
And that's this one,
So
right?
yeah, so that's how many delays that they had, but is that a percentage of how many delays they had versus total orders that they shipped?
No, it's a accumulation of days, total days late.
Oh, okay, okay.
And
But no,
And
Jody,
that's
just
a good point. That's kind of goes back to what Bill was saying is like, does the number of open orders correlate to on-time shipments? Does
right, or
right,
if there's yeah, if there's any one shipper that tends to be, have delays more often than others, something like that.
right. Hmm.
Hey, Doug, you got something?
Yeah.
Doug Morrison.
How you doing, everybody? I looking at this particular uh slide you have up here. You have delays by shippers. Did you have any other sources of delays, or did you determine that this was your biggest source of delays?
Um, I think because the data was a little bit like limited, we just had that shipper information. So that was why we correlated it to the shippers. But we would probably need more information or more data to make it, more correlations other than the number of open orders during that time frame.
Thank you.
How about Bev?
Yeah, Jody, I was curious, just from my knowledge, was this just specific to distribution or was it Hubbard Hall as a whole for the whole ordering
It's
process
it's as a whole.
as a whole? Okay,
Yeah,
thank you.
So it's all
And I think
locations.
to buttress that, it was Jody, I think it was data set from January up to July of this year, correct?
correct.
Okay,
Yeah.
thank you.
This, Bev and Jody work together on the customer experience team,
Yeah.
and it's just constantly just getting better and better. Yeah, and I think in the business, tough business you guys are in, thank God they got you guys. Let's
Oh,
see.
thanks. It is tough.
Hey, who else? Who else? Somebody else had their hand up, I think, or no? We all set?
Well, I'll say I don't have any comments or questions on the data specifically, but I think both presentations so far have been great. I mean, you guys have done an awesome job of making the data visual and really being able to see, where the difference lies. So great work.
They're making
Awesome
it
stuff.
scream, aren't they?
They are, for sure.
Yeah. All right, I think I'm gonna have to switch give somebody co-host. I don't know who wants to be next. Um,
My group doesn't mind going next, Bill, if you
all
want
right,
to just give me
Jason
the
Rose.
screen share. Yep.
All right, Jason Rose.
All right, let me see here. Oh,
There
looks
we
like it's
go.
not turned on yet.
There you go.
Perfect.
Albrecht Steel in the house.
All right, everyone able to see my screen?
Yes.
All right, perfect. So my group was myself, Bev, Tyler, and Craig, and we studied temperature-driven demand curves in dairy-based consumer products. In other words, how heat drives treats. So basically, we got all of the sales data from the Froyo shop from 2014 to 2021. We were able to get weather data from 2019 to 2021. So really, there's obvious seasonality when it comes to something like frozen yogurt, but we wanted to quantify exactly what that looked like. So basically, to start at the end, the summary of our findings were basically that for every 1 Fahrenheit increase in average temperature, that made sales rise about $40 to $45. No surprise that seasonality was the biggest driver. Both looked at the max temp and then also the feels like temp to kind of see if there was any kind of difference in basically what the outside temperature was versus what it felt like based on things like relative humidity. They ended up kind of measuring nearly the same thing and having the same effect. The bottom line at the end of the day was obviously that temperature is a strong, reliable indicator of demand. So starting first off, just looking, at sales trends over time, it's really obvious just at a cursory look that there's seasonality to this. You can see the dips and the curves. Sales peak during the warmest months, drop during the coldest months. There's some different variants out of that you might link to events like a summer holiday weekend, special promotion, or anything like that. And really just overall, the largest takeaway, obviously, from an operational standpoint is the inventory, staffing, and marketing should scale with temperature trends. So even taking a step back further, let's look at what the sales looked like when plotted as a distribution. So you can see here that our mean sales were 4,431 with a standard deviation of 1,798. So most weeks are clustered around the average, but you do kind of see a right-hand tail. These big spikes represent exceptional weeks, often tied to extremely warm weather and busy weekends. So again, once again, confirming that there's a solid baseline of sales, but the largest surges were almost always weather related. So breaking it down even further, most weeks fall into that $1,900 to $2,800 range, which we kind of considered our baseline performance under typical weather conditions. High revenue weeks in the $7,000 to $8,000 range are rare, but they kind of consistently aligned with peak summer heat. And even within that baseline, though, there's some moderate variation, which kind of suggests roles and factors beyond temperature. I don't know what kind of marketing efforts or kind of local events maybe played a role in foot traffic. Importantly, of course, sales never dropped to zero, so there was kind of a steady overall customer base. Now getting into the good stuff about exactly how we kind of looking at the overall sales data and obviously realizing that sales was an important or seasonality was such an important factor to kind of quantify that exactly with some regression mapping. From a statistical perspective, the correlation between temperature and sales was moderate but meaningful, about 0.48 for maximum and feels like temperatures. P-values, as would be expected, were extremely, extremely low. The R squared kind of shows that the metrics explained for about 22 to 23% of sales variation. Again, confirming that temperatures aren't the only factor. They're just one of them, but in retail terms, I mean, 22 to 23% is obviously a huge, huge, huge factor.
We should have done soup, huh? In the cooler ones.
Yeah, that's true. Looking closer at the regression analysis, the slope is where we get that, the exact increase. So you see 45.05 for the max temp, 41 for the feels like temp. So, that's basically showing at the end of the day, quantifying exactly how the temperature affected the sales. We tried running, as I said earlier, both kind of within the same model. It works the same, though. They're really measuring very, very similar things, and max temp alone was really the strongest predictor that Bill could have undertaken when operational planning for the shop.
Wow. My mind's blown. My mind's blown. With that correlation, it's like you say, oh, how many people do I need to staff? I know if I can have an accurate weather report, in terms of how many people, how much inventory, because you can still make money, you know, with lower sales. It's just that was really cool.
Yeah, after the other presentations, it immediately had me thinking what we were doing was since we had weekly sales data, we were correlating. We basically took the temperature for every single day of the week, averaged it out, and then used that to compare against the sales number. But if we had had sales numbers for every single day, it would have been really cool to find out how much like a hot day during the week versus a day on the weekend had an impact.
The problem is, my wife and I, we did not have you guys. We didn't have Bev, Tyler, Craig, or you to help us back then. So that's why we sold it. Oh my, that was any questions, guys? That was brilliant. That was brilliant. That was a first. Questions for Jason and team? Well
That was
done,
very
guys.
good.
I think I
Excellent.
forgot to tell you, Wednesdays was $5 fill your cup. So we get a spike. We get a line out the door on Wednesdays, but we lost money. So $5 fill your cup.
So we also looked at the NCAA um, penalty statistics, specifically around defensive pass interference
Oh,
calls
nice.
on for
Oh
games that
my God, that's
you're the
hilarious.
back judge
Very
for.
low, very low.
Yeah, there's some statistical significance there, though, Bill.
Yeah, you have to behead somebody for me to throw a flag. So nice job, guys. Nice job. And last but not least, who's doing the talking for group four?
I can share my screen for
All
my
right,
group.
Meg, I got to make you a captain. I mean, co-host. I'm sorry. Co-host. Meg. Perfect. 3 for 3, man. Perfect.
Okay, let's see. All right. Can everyone see my screen?
Yes.
Yep.
Okay.
Oh my God, I'm pumped. PTA now. Oh my God, I love it.
So our group consists of Nick, Alec, Darnell, and myself, and we completed our analysis on some scrap data pulled from PTA. So for those who don't know, PTA Plastics is a plastic injection molding manufacturer. Some of our main products are casings for medical devices like veterinary equipment and defibrillators. Over the past few years, we've noticed consistently high scrap for one of our AED substrates, which has led to customer returns and increased inspection protocols, which is just kind of a headache for us. It's a waste of our employee time and our material resources. So I thought this project would be a really good way to pull some information out of our existing scrap data to help us reduce or eliminate the issue. So some questions we want the data to point out for us are what scrap defects are the biggest contributors to our waste, and is scrap dependent on or correlated to certain factors that we can control?
Uh, Here we're applying the 80/20 rule to our scrap data. The idea behind the 80/20 rule is that about 80% of the results come from 20% of the causes. In our case, that means a small number of scrap sources are likely responsible for most of the total scrap quantity. So if we take 20% of the scrap quantity, 18 units, that's 3.6. This tells us that we should focus on the top 3 to 4 categories with the highest scrap counts. Looking at the cumulative percentages, 80% of the scrap falls between third highest category, blush, which accounts for about 78.5%, and the fourth highest, startup, which takes us to about 85%. It's important to remember that the 80/20 rule is an exact mathematical law. It's a rule of thumb that helps us focus on the most important areas. In this case, the 80/20 pattern does apply. So our improvement efforts should target display first, as is the major driver of scrap. You're good to go to the next slide.
Yeah, so this is the scrap data for the specific 150 display scrap code. Sort of the key takeaway here is that it is a right skewed chart or a positive skewed chart. And it could seem as if it's out of control, but in fact it actually is in control. However, a better way to put it is that there is a decent amount of variation within the scrap data points. So going forward, it might be beneficial to do a root cause analysis to understand why that's happening and maybe find ways or solutions as to lowering the actual variation. Next slide. Yep. So this chart shows how many standard deviations each point is above or below the mean, which is on the y-axis, and then the x-axis is the actual scrap quantity for each data point. And then the closer the data points are to the trend line, the more perfect the process is. So obviously there's some room for improvement here.
So we have the correlation, and we got explain contamination, the data, and explain contamination according to the data obtained for the list are not linear. They are not driven by the same problem. There is not a correlation between display and contamination according to the graph and the numbers that we ran on this correlation. Thanks.
Wow. 0.05 or 0.005?
So now that we have kind of narrowed down display as our biggest contributor and eliminated its correlation to other scrap codes, we can kind of isolate what the root cause of display might be to figure out where to begin with reducing it. So here is a fishbone chart that lists different factors that can cause splay. So for reference, splay is a visual defect that appears as kind of a cluster of white streaks on the surface of a molded part. It's essentially a bunch of gas bubbles that get pushed or dragged through the plastic during the molding process. So the most obvious contributor of gas bubbles would be moisture in your material. So that's why I have like under the material section, moisture in the resin before it goes into the machine. That's going to cause some of those gas bubbles to get trapped. Kind of going hand in hand with that under the environment section is moisture in the air on the production floor. If it's a hot, humid day, there's going to be more moisture in the air, which could lead to higher levels of moisture in the material. Another key one on here under machines are the dryers that we use. So the dryer is what's going to take the moisture out of the material before it goes into the molding press. If our dryer is the wrong size or we're not getting the right throughput, we could have wet material going into the mold. So These are just some root causes. I think this chart helps us get some starting points of where to start with reducing the splay.
Now here's our control chart. Overall, the process appears statistically stable. Every scrap measurement is within the control limits, and with the upper limit about 448 and the lower one being 0, as it can't be lower than 0. Like Nick said earlier, the variation is large. And we can see some spikes like on October 25th, 2023, March 25th, 2025, where scrap quantities are unusually high. Well, these spikes aren't technically outside the control limit. It could be signs of special cases worth investigating. So yes, the process is stable, but it doesn't mean it's capable of meeting tighter scrap targets, especially if our goal is to consistently stay much lower. We found one correlation as higher scrap tends to occur between March and August. This matches the seasonal rise in humidity, which supports the theory that our splay issue may be linked to moisture-related material degradation.
On conclusion, the 80-20 rule tells us that we should target splay contamination blotch, which are the defects caused by major scrap. Splay contamination are driven by the same problem. There is a potential correlation, high splay and more humidity in the months summer.
Bang.
That's pretty much it.
Wow. Incredible. Guys, well done. Any questions for these guys? PTA is probably one of the best in the world at what they do, and I just love just again that Greg, anything? Doug?
No, nothing from me. I mean, I guess I am curious as to which part that was, but I can guess we can talk about that offline.
Was it AED?
Yeah,
you're
it's
right.
the front substrate for our AED.
Yeah. Well done, guys. Now, this recording is going to be used for future classes as the model for how to do presentations because it was really good. I've had some that go 5 minutes. You guys, everybody made data scream. The next step now is tomorrow I'll be at PTA and I'll have mugs for you four. And unfortunately for you guys, I'll show you what the mugs look like. Some of you guys have them already. I mean, Greg and Tyler and I also, unfortunately for you guys, my garden, I just got I picked 6 gallon bucket full of squash and cucumbers. So you're going to get that too. Pose for a picture. And then on Wednesday, I'm going to go see Nick. And then on Thursday, if I'll be at PTA, I mean, at Hubbard Hall, and I'll bring the mugs in, probably either squash or cucumbers too. And then I'm going to get to Jason and Marissa. And Alec, you're probably going to have to come to my house maybe. Riyadh too. I'll meet you guys somewhere. But over the next few weeks, I want to get your mugs to you. Congrats. Well done. So proud of you.
Really good.
These are the best set of presentations I've had, right, Greg? I mean, they're really good.
I
Good job,
mean,
everyone.
I was in this class too. I'm a little offended, but
I know.
yeah, no, very good.
You guys nailed it in compared to these people.
Oh, so funny.
All right, I'm gonna send the recording for the last time. I mean, I think at the next class, I'm thinking middle October. So if you guys have people that might be interested in the torture, let me know. And I'll
Sounds
have
good.
them. Yeah. Well done, guys.
Bill, thanks very much.
Thanks so much,
You are
Bill.
absolutely welcome.
Thank you.
Thank you.
Great work,
Thanks, Bill.
everyone.
Thank you, Bill.
Thank you, Bill.
You're welcome. You guys.
Everybody have a good one.